My topic to present here is dielectric constant. So, our aim is to study the variation of dielectric constant with temperature and to determine the Curie temperature. Now, let us move on to the theory part. What is a dielectric constant? A dielectric constant is defined as the ratio of capacitance of the material, that is C, to the capacitance of the free space, C0. So we can write K is equal to C by C0, where K is the dielectric constant. Also, we have equation for C0. C0 is equal to epsilon 0 A by T, where C is the capacitance using material as dielectric and C0 is the capacitance using vacuum as dielectric, and epsilon 0 is the permittivity of free space and A is the area of dielectric and T is the thickness of dielectric. Another definition for dielectric constant. It is a measure of amount of potential energy in the form of induced polarization stored in a given volume of material under the action of electric field. Also, we can say that it is a ratio of dielectric permittivity of the material to that of vacuum. So, we can write K is equal to epsilon by epsilon 0, where K is the dielectric constant. For a parallel plate capacitor with a dielectric between its plate has a capacitance C is equal to K epsilon 0 A by D. Now let us see what is Curie temperature. It is a temperature at which spontaneous polarization disappears. An increase in the temperature leads to the increase in the charge of capacitor. Also, the dielectric constant increases up to Tc and it decreases above Tc. This Tc is the transition temperature. Below Tc, the increase in dielectric constant is due to the increase in polarization arising from easy orientation of dipoles. And above Tc, the decrease in dielectric constant K is due to increase of thermal oscillation of molecules and increase in the degrees of disorder of the dipoles. Also, above Curie temperature, the spontaneous magnetization of a ferromagnetic material vanishes and it becomes paramagnetic. So, we can obtain the Curie temperature from temperature dielectric constant plot. Now, let us learn about barium titanate, that is BaTiO3. Barium titanate is a piezoelectric ceramics which have a cubic peroxide structure. Its chemical formula is AbO3. Actually, this peroxide is a family name of group of materials, for example, calcium titanate, etc. In barium titanate structure, the barium cations occupy the corners of a cube and the titanium cations is present at the body center and the three oxygen atoms per unit cell rest on the faces. So, in the figure we can see that barium is present at the corners, titanium at the body center and oxygen at the rest of the faces. Barium titanate possesses a ferroelectric tetragonal phase below Curie point about 120 degrees Celsius and paraelectric cubic phase above Curie point. The temperature of Curie point depends on the impurities present in the sample and the synthesis process. In paraelectric cubic phase, the center of positive charges coincide with the center of negative charges. So, the center of positive charges are barium, that is Ba2 plus, and titanium, that is Ti4 plus, and negative charges are O2 minus ions. So, on cooling below Tc, the tetragonal phase develops. And here the center of positive ions are displaced relative to the negative ions, i.e. there forms electric dipoles. It is mainly used in multi-layer capacitor applications. One of the main advantages is that many cations can be substituted on both A and B sides without changing the overall structure. Now let us move on to the procedure part. Put a small piece of aluminium foil on the base plate. Now put string loaded probe upwards. Then insert the foil. Allow them to rest on it. Now pull the sample of barium titanate on the foil. Again pull the top of one of the probe and insert the sample below it. Let it rest on it gently. One of the probe must be in contact with the upper surface of sample and the other one must be in contact with the lower surface through aluminum foil. Now connect the oven to the main unit and put oven in off position. Switch on the main unit and note down the values of capacitance, and it should be a stable reading. Now we need to switch on the temperature controller. Then the lightning indicates that the oven is in good condition. Now we can observe the variation of dielectric constant for each temperature. Also we need to observe the cooling process and measure the dielectric constant. Now a graph can be plotted for temperature along x-axis and dielectric constant along y-axis for both heating and cooling. By following these steps, we can study the variation of dielectric constant with temperature and also find the Curie temperature from the plot. So, we obtain a Curie temperature about 120 degrees Celsius to 130 degrees Celsius. So, that's all about my topic. Thank you.